Okay, the last section of 3.4 is multi-step inequalities, and we're going to consider some special cases on these inequalities, and then we'll do some practice problems. Okay, so we're going to solve the inequality, then graph the solution on a number line. Okay, so for example 1, it says 7x plus 5 is less than or equal to 3x minus 11. There's more than one way to solve it, so you might do it differently than me, but as long as we have the same result, we're fine. Okay, so since I have a 7x on the left side and a 3x on the right side, I'm going to cancel one of them. I think I'm going to cancel the positive 3x, so I'm going to subtract 3x, and I'm going to line it up under the like terms. Okay, 7x minus 3x is 4x plus 5 less than or equal to, these cancel, and that is a minus 11 I'm bringing down. Okay, I'm going to go ahead and keep solving this. Now it's a two-step inequality. So since it's 4x plus 5, I will minus 5. 4x less than or equal to negative. Since they're both negative, I want to add them up. Negative 11 and negative 5 makes negative 16. Okay, one last step. Divide 4. Divide 4. X is less than or equal to negative 4. Okay, I finished solving it. I did not switch the inequality because I divided by a positive 4 on both sides. Okay, I'm going to go ahead and sketch my number line. So if this is negative 4, this must be negative 3, and this must be negative 5. It's a closed circle because it can equal to negative 4, and then the numbers that are less than negative 4 are to the left. Okay, let's go ahead and try example 2. Example 2 says 3x minus 4 is less than 5, parentheses x plus 2. Okay, let's see. Since there's parentheses, I'm going to go ahead and distribute first, and then I'll try to solve it. So 3x minus 4, 5 times x is 5x, plus 5 times 2 is 10. Okay, and again, there's more than one way to solve this, depending on how you would like to do it. I'm going to subtract the 5x, although you might want to subtract the 3x, depending on if you like negatives or not, because 3x minus 5x is negative 2x. Less than, okay, the 5x's cancel, and I'm going to bring down a positive 10. And if you did it differently, we should end up with the same number line at the end, so it's okay. Okay, let me do plus 4, plus 4. Divide by negative 2. Okay, since I divided by a negative 2 on both sides, I am going to switch the inequality. So x is greater than negative 7, and if you did it opposite me, you would have negative 7 is less than x. Negative 7, negative 6, negative 8. This is an open circle because it cannot equal to the negative 7, and the numbers greater than negative 7 are to the right. Okay, the next two, we're going to have something interesting happen. Okay, but we're going to try to solve it the same way. 6x plus 11 is less than or equal to negative 7 plus 6x. Okay, I do have x's on both sides, so I'm going to cancel off the positive 6x. I'm going to subtract 6x. Okay, what happens when I do this? Okay, these cancel, and I bring down positive 11. Bring down the negative 7. Okay, but these also cancel. Okay, I'm left with 11 is less than or equal to negative 7. Okay, so I have no x left, so I can't really solve for it. So this is an unusual situation. So I'm going to look at the final statement I have right here. This says 11 is less than or equal to negative 7. This is either going to be true all the time or never true. And that's going to tell me what kind of a solution I have. So is 11 less than or equal to negative 7? No, 11 is not lower than negative 7, and it's definitely not equal, so this is false. Okay, because this is false, this actually means that there's no solution at all. Okay, there's no number that would work for this inequality, no matter what I plugged in. So what would I put on my number line? I'm not going to color anything in. If you want to show it's no solution, there's a little abbreviation. You can either just leave it blank, or you can put the 0 with a slash, and that also means no solution. Okay, now example 4 is going to have another weird thing happen to it. It says 4 parentheses x minus 3 is less than 4x plus 5. Okay, I'm going to go ahead and distribute. So 4 times x is 4x minus 4 times 3 is 12. And I'm going to bring down the rest. Okay, I'm going to cancel the x's off, although you could do it differently. I'm going to subtract 4x. Okay, this cancels, so I'm going to bring down negative 12 and this symbol. Okay, this cancels, and I bring down 5. Okay, All my x's are gone, so this is either going to be a true or false statement. So is negative 12 less than 5? This is true. Okay, what does that mean for my answer? It means that all real numbers will work in this situation. You don't know exactly what real numbers are yet, but no matter what number I plug in for x, it will always be true. Okay, so then what do I do on my number line? Okay, since all the numbers on the number line work, I color the left arrow, I color the right arrow, and everything in between. I don't have to label any points because every single number I labeled on there would be correct. Okay, that's the two weirdest situations we could have. We're going to go ahead and do the 3.4 practice in class, or you can click the link on the table of contents.